Problem 1. A ladder is needed to reach a security camera that is attached to the outside of a building at a point 15 feet above the ground. Safety regulations require that the angle the ladder makes with the ground should not exceed 75 degrees. How long will the ladder need to be? Okay, the first step in solving any applied trig problem will be to make a sketch, provided the author of the problem didn't give you one. So in this case, we need to make a sketch. So the first thing we need, I guess, we need a ladder, and we need a building, and we need some ground. So here's the ground level, and here's the side of the building. And let's say that right here is the security camera. Now, the ladder is going to extend from the security camera down to the ground. So I'll draw the ladder as this line. So there's the ladder. And the angle that the ladder can make with the ground can't be more than 75 degrees. So to get the shortest ladder we can, we should make it 75 degrees. And the person climbing the ladder then will be living on the edge of the safety conditions. Now, assuming the building is at perpendicular to the ground, so we'll make a right angle there. And so we have a right triangle in this situation. Now, the thing that we do know, the known distance is 15 feet. The camera is 15 feet above the ground, so I'll put the 15 feet in. The thing we want to know is the length of the ladder. I'll just use L to stand for the length of the ladder. So now we have a right triangle, we have a known angle, we have a known side and an unknown side. So this is a typical right triangle application. And so the first thing to do is identify the sides that we know and we want to know, identify what they are in the generic sense of adjacent, opposite, and hypotenuse. So if we look at the angle 75 degrees and we look at the height of the camera at 15 feet, that side of the triangle is opposite to the angle 75 degrees. Then the ladder, which is what the side we want, the length of the ladder, that forms the hypotenuse of the right triangle. So hypotenuse is the ladder. So the opposite is the known side, the 15 feet, and the hypotenuse is the ladder. And so we have to think about what trig function involves opposite and hypotenuse, and hopefully you know that the sine of an angle is the opposite divided by hypotenuse. So we can fill in the blanks now. We would have the sine of 75 degrees is equal to 15 divided by L. Now, at this point, the trig is over in the problem. We've set up the trig ratio and we have an equation. And this equation is just like many equations you've solved in your algebra history. And so we just have to solve this equation. Now, the unknown, the thing we're solving for, is in the denominator. So we need to try to remedy that, get it out of the denominator. So if we multiply both sides by L, we'd have L sine of 75 degrees on the left side. On the right side, we'd have 15 divided by L times L. The L's will cancel. And so we end up with L sine of 75 degrees equals 15. Now, once we have transformed the equation to this, then the final step is just to divide through by the coefficient of L. Coefficient of L in this case is a sine of 75 degrees. So L equals 15 divided by the sine of 75 degrees. Now, so we've solved for L, and if we didn't care to do anything like buy a ladder, then you could stop right here. This is the solution. However, if we want to buy this ladder and know how long it needs to be, we need to get the decimals for this. So L is approximately, using your calculator, approximately 15.5 feet. So we need to buy a ladder that's at least that long. The ladder could be longer, and that means that the person climbing the ladder would be able to put it at a lesser angle than 75 degrees. But at the very least, we need a ladder that's 15.5 feet. And this would be the end of problem 1. Problem 2 says, a trig student is taking a vacation in the Sequoia National Park, and he decides to apply his trig to determine the height of a really tall tree. Like any dedicated trig student, he has his clinometer along to measure angles. Starting at the base of the tree, he walks away a distance of 90 feet. Then sights the top of the tree with the clinometer and records the angle to be 71 degrees. If his eye level is 5.8 feet above ground, how tall is the tree? So again, first step is to make a sketch. So we need this really tall tree, which will be here, and we need the ground here, and assuming the tall tree is straight up, this would be our right angle, and I'll put a little top on the tree and a couple of branches. A really tall tree. Now, that's the thing that we want to know the height of. So is H is this height. Okay. Now, the trig student has walked from the base of the tree. He's walked away 90 feet. And so here's the trig student. Here's his eye. Here's a smile because he enjoys doing trig in the real world. And here's his arms and legs. So, there's your trig student. Now, we can make a triangle that has the base along his eye level to the tree, and it has his line of sight to the top of the tree. And the tree itself forms a right triangle. So the right angle now is up at the line of sight. We know that this distance is 90 feet. That's how far he walked away. And we know that this angle is 71 degrees. So we want to find the height of the tree. Now, the height of the tree is going to be the height from the top of the tree down to the eye level, plus the distance from the eye level down to the ground. So I'll call that first distance from the top of the tree to the eye level, I'll call that y. And then h will just be y plus his 5.8 feet up to his eye from the ground. So the real problem, the trig problem, is to actually solve for y. So we have to do the same thing we did last time. Think about which side of the triangle is y and which side do we know, and relative to the angle 71 degrees. So 71 degrees, if we look across from that angle, the opposite side is y. Y is the opposite side. to 71 degrees. And the adjacent side is the known 90 feet. So 90 feet is the length of the adjacent side. So this time we need to relate adjacent and opposite. So, of course, the trig ratio that you need to remember there would be that the tangent of the angle is the opposite over the adjacent. Now, if we apply that to this situation, we can say the tangent of 71 degrees is the opposite, which is y, over the adjacent, which is 90 feet. So now, again, the trig is over. We have an equation that involves a trig function, and we can solve this equation for y. In this case, the equation is one step. We have to multiply both sides by 90. So 90 tangent of 71 degrees would give us y. And to get decimals, we use the calculator. The calculator tells us that the y distance is 261.4 feet. Now, that's almost the height of the tree, but being a precise trig student, we take into account his eye level is 5.8 feet above the ground. So the height of the tree then is 261.4 feet plus the 5.8 feet for his eye level, and that comes out to be 267.2 feet. And as the trig student has observed already, it's a really tall tree. And that's the end of problem 2.